guys, this is Drone. To my right,
soaring
moon.
I'm soaring moon this episode.
Because space.
Because space. And this is Kaboom.
Not space.
No, not really.
You are Kaboom 522666.
It's true. Because it spells something. Kaboom, kaboom.
Kaboom, kaboom.
Kaboom, boom, boom.
Boom, 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 boom.
Zoom,
anyway,
zoom, zoom.
so let's ask.
Make your heart go
soaring...
boom, boom, boom.
You can ask me too.
If anybody gets that reference,
I'm
I
gonna
will
ask
give you a
soaring
cookie.
questions about space because we once spent, I don't know, like 3 hours in Wendy's waiting for you to pick us up.
Talking about space.
Talking about
Ask me
space.
questions about space.
Oh man, you know what? Fuck you.
It's true. We were waiting on you. Worthless. All right, come on.
Okay,
Throw 'em at me.
The alcoholic cloud that's
Alcoholic cloud? Okay. So you're talking about the nebula,
yes.
right? Just by mere reference, that apparently smells like rum, tastes like raspberries.
Yes.
Okay. So that nebula has a 2% concentration of this chemical. I don't know the name of the chemical right now on the top of my head. I could probably look it up. But it's thick enough to where if you were to open your face mask in space, I hate to tell you this, but yes, you can survive that for up to 30 seconds.
It's true.
Take your face mask and breathe it in. It would be thick enough for you to actually breathe, right? It would be thin, right? Of course, it's not going to have a low air pressure, but you could breathe it in, and you would taste this. And if you close your face mask left enough or quickly enough, you will only suffer minor injuries. Yeah.
You would probably not actually even face.
Yeah, you go there, take a deep breath in, and close it immediately. You will suffer minor injuries. You'll be fine.
Yeah, and it wouldn't be what most people would think. It'd be probably frostbite.
It'd probably be frostbite from you taking in the influx of cold.
Though I will say, I don't think it would actually be.
It might actually be very warm as well, because that is a stellar nursery.
Yeah, that's true.
Yeah, I mean,
or it could cause third-degree burns to your lungs.
It depends on how close you are to a star. Really, if you're within the star's habitable zone, not the one where planets actually absorb heat. Like the point where it is actually room temperature outside in space. Right?
Yeah,
which is probably like I'd say not Mercury's distance away, but halfway between that and Venus. You could probably take your face mask off, be relatively unharmed. But except for by the vacuum of space, your lungs would compress, and you would have to put your face mask off to take actual breaths of air. Again, you're going to suffer minor injuries.
Don't face the star because then you will actually be subject to direct radiation.
Yep, face away. Actually,
face away.
No. Stellar radiation is interesting. The concept, you can go to solarham.com. That's solar SOLAR ham HAM.com.
Oh.
As in solar ham radio, not like okay. And what they do is that it shows you everything you need to know about the fucking sun, right? And
That's
it
cool.
only releases radiation once on every 23-hour intervals. So you can actually get into a band where they're not releasing any radiation at all. It's because it only comes out of the poles of the sun.
Oh, yeah, you're right.
Yeah, and as it spins, it just spews it everywhere. But it's interesting. You don't need to know that. Other questions about space, objects in space.
Objects in space. The planet made of diamond. Is that true or false?
Okay, the planet made of diamond. If you don't know how we search for exoplanets, we point very powerful radio telescopes in front of stars, and as planets pass over them, the amount of starlight it emits decreases, because obviously, whenever you put your finger in front of the sun, it eclipses it, right?
Right, of course.
Okay, so that's how we detect that. It just decreases the amount of light. It's too far away. It goes from, 100% emission to a known value we've always known for centuries to 99% of that's value, then back up to 100%. And realistically, it's 99.96 of its value, and then it just goes over there. And it's trackable, that amount. But whenever that sunlight changes, right, the sunlight that goes through the atmosphere of that planet will have a different radio frequency. It emits a different kind of light. And we can detect that light and then cancel it out with the light emitted by the star and find out what's left over. And when we finished that process, what was left over was a signature from carbon, and specifically crystalline carbon from diamond and lysandrite, also known as double diamond. So we can assume that in or on this planet, we just the media said, "Oh, it's made of diamond," when in actuality, it could be that there's diamond particles in the air on this planet. We don't fucking know that. Like, it could be raining diamond on that planet.
Yeah,
that's how we're catching the light refractions. Or the planet could be legitimately covered in a coat of diamond. It's very possible. And I would say that if you found a very large source of carbon out in space, and a star managed to compress it down, or a heavy planet managed to compress it down, it could make an entire planet of diamond, and then kick it out into the solar system after a star exploded, or a nova, or something like that. It's very possible, and this thing captured it. But it's more likely that it just creates... the planet's just heavy enough to where it just creates this,
right.
all the time. It just has a really dense gravitational field. It could be some kind of very, like, blue dwarf or something weird like that, where it's, we don't know. Because we can't determine the size of the planet from this information. We can only determine its composition, its distance from the host star, and potentially its size, if we can detect the difference between the emission of light. If it's too far away, we can't. And it's that simple, really. If we're looking at the light, we found the light it matches the signature of diamond and lysanderite, and after that, we make the speculation that the planet's made of diamond, but that's just mostly hype.
Yeah, it's...
Mostly. We hope!
I know. It could very well potentially be made of diamond.
Okay.
That's within the realm of possibility.
Fine.
Other objects in space. Go.
Okay, so something I would like for you to explain, because I know you know about this.
Right.
How would you like to explain the different stages of ice that we find in space?
Okay. That's easy. So.
This includes, you do know that there's a core of a planet supposedly made out of ice 7.
Oh, yeah, okay. All right.
Yeah, you know what I'm talking about.
Yeah, I know what you're talking about. So.
They actually have something to add on to that. Supposedly, they found a planet of burning ice.
Oh, interesting. I'll get to there.
I know what you're talking about.
Okay, so. Talking about the stages of ice. So, are any of you familiar with Pascal's principle?
Nope.
Okay, I'll explain to you Pascal's principle. As air pressure increases, the temperature required to heat something to boiling also increases. Got me so far. That's all you need to know. So, whenever you say, if water is under high pressure, you require a lot more or less energy to freeze it. And there's a table for this. Right now, at room temperature, right, it requires 212 degrees Fahrenheit, 100 degrees centigrade at sea level to boil water. As the air pressure gets lower up here in Indiana, where we're 3,400 feet above sea level, water actually boils at a lower temperature. Boils at 211 degrees Fahrenheit.
That's why I can stick my hand in it.
No, that's not true. That's
not just boiling. Just boiling.
Okay. But if you increase the pressure, it requires, higher temperatures. But also, other things happen whenever you pressurize water. For example, normally when you crystallize water, it creates a, what's called, it's just a lattice, where all of the random water molecules just are randomly composed into a rigid formation, and there's no happenstance about it. That's why whenever you freeze water, some weird things happen. Like if you freeze at a really solid temperature, like negative 14 degrees Fahrenheit, if you put that in your freezer and you manage to get that exact temperature, the water pressure of the ice pressing down on the water inside your ice tray will force shoots of water to come out of the ice tray and make spindles.
That makes me think of I don't know where I watched it or how long ago it was, but I was watching something on TV that explained how they make the clear ice for like water sculpture. Ice sculptures.
That's easy. You need water without purities, okay, without impurities. So you have to use distilled water. That means they basically usually it's vacuum distilled, where they force it through a plate and they just keep all the bad stuff and leave just pure water on the other side.
Yeah.
Or they literally distill it by heating it up and refreezing it, heating up and refreezing it. Sometimes it's distilled like 7 or 8 times.
Yeah.
And that's cheap to do because water's everywhere. So distilling, like, it's different with alcohol. You can only distill it 2 or 3 times before you start getting losses of alcohol in the process. through evaporation and whatnot.
Well,
for water, it's all just, you open the tap and you just run the distillery until it's finished. Once you have this, right, when you freeze it, it creates a regular lattice because there's no impurities for the other molecules to stick on in random directions. It creates a nice gridded lattice, and that, in fact, is ice too.
Crystalline lattice.
So a crystalline lattice, where it's continuous, it's a square shape. Now, you can actually change this lattice by increasing the pressure, right? And it also forces the water molecules to stick rather than... water molecules are in the shape of V's. Normally, the V's like to stay together in like a... best described as a triforce, just continuous like V formations on top of each other. And that's a very regular square kind of cube formation. But sometimes you can get these to sit inside each other, kind of like scissoring molecules, and that'll create an octahedral lattice like a D8, octahedral 8, where that is ice 3, and then higher pressures will create hexagonal arrangements. Ice 4, Ice 5, Ice 6, then Ice 7, Ice 8, and Ice 9, not to be confused with the books. It's not an Ice 9 reaction, it is a Ice 9. Those are all those are way more like complex arrangements. And as you get higher pressures, the arrangements get more complex. Sometimes they even have what's called a conical fracture. I don't know if you've ever broken obsidian. Right? But you cannot cleanly break it.
No.
Whenever you hit it, it just chips off circles. Right? And that's the same that happens with, I believe, Ice 11, Ice 12. And we have, I think, 18 different types of ice. Many are undiscovered because we can't reach those pressures. But the inside of planets can. So we've actually discovered some of these ice formations by using scanning spectrometers and stuff like that, just like we look for exoplanets and stuff like that.
Right.
Yeah.
And you mentioned the core of a planet that we found that it was made of ice. We found that it was, because of the spectrometry, we seen that it was made of either Ice 7 or Ice 8 or Ice 9. And it's hard to tell which, because they are very similar spectrally because they have the same conical structure. It just depends. The amount of pressure that something has will change its structure completely. Things about Ice 9 reactions, by the way. An Ice 9 reaction, if you're familiar with the book, I don't remember what book that's from, but an Ice 9 reaction, basically, it's they said it was this object, when you dropped in the ocean, that was the goal of this, that would freeze all water on the planet. It would just crystallize all the water on Earth.
I didn't know this was Superman.
It's Ice 9 was a thing where it would, you drop it in there and it crystallized off of the seed crystal, and that I can assure you it's not possible because the impurities of the water of seawater, it's just not going to happen.
I'm pretty sure you're happy I brought that up.
Now you can do it with distilled water, and it has accidentally happened to you.
Yes. While I was
if the water is supercritical, you don't even need a seed crystal. You just need to violently agitate it, creating a nucleation site by a pocket of air, and it'll just all freeze all at once, which is pretty cool.
But burning ice.
Oh yeah, burning ice.
Burning ice.
The burning ice is relative. There are many types of ice. There's of course dry ice, which is CO2 ice. There's methane ice, right? The methane ice is the one you're referring to because methane is very flammable.
Well, yeah.
But they do not mean water ice. They mean methane ice.
Methane
well,
ice.
How it was explained is that the pressure that the planet puts on the ice
and actually
wouldn't allow the ice to melt with the fire that went over it.
Exactly. But the ice that they're talking about is methane ice. Okay. Almost certainly. Because I can tell you for certain, under any condition, water is not flammable.
Talking about methane, I believe it is Titan.
Titan.
Can I explain this one? Because I actually know this. Okay, so you do know about Jupiter. Titan, the moon of Jupiter, has a liquid methane ocean. 3
liquid methane oceans. And not 2 are liquid methane. 1 is liquid kerosene.
Yes. And the atmosphere the atmosphere actually can freeze part of this and create the same exact thing that you're trying to talk about in the last.
Interestingly enough, the air on Titan is so thick because Titan is nearly the size of Earth.
Yeah.
If you were to bring a pair of wings with you like, I mean literally some cardboard strapped to your arms, and flap it, you could literally fly.
Now, I am going to say this. We have found fires burning on Titan because it has these weird, random electrical storms.
Right, that set off just parts of the lake.
Just set things on fire.
And the funny thing is, because there's not enough oxygen in the atmosphere, it releases CO2 gas into the atmosphere, and that breaks down into carbon and oxygen over time, and creates new hydrocarbon through rain, and then proceeds to burn again. Yes. So the fires never consume the whole planet, it only consumes portions where the oxygen concentration is high.
High. Yeah.
Which is, it's this awesome equilibrium.
Every once in a while, you'll just see this huge...
Now, being able... Just
Titan.
wait until we can harvest that shit.
By the way, there is enough gasoline on Titan that we cannot bring it to Earth because burning all of it would ruin our ecosystem. It literally would. Like that when we're talking about global warming, that amount of hydrocarbon is ludicrous.
Yeah, that's the kind of thing
The only reason we would ever use that amount of fuel is to be on Titan. Doing something on Titan. And, like, literally. We can't bring it back.
One more thing, because I know about this one as well. One other thing that I want to bring up is Io.
Io.
Because
the volcano world.
Io is the only, as last I checked, is the only other place in our solar system where we have found water.
No.
No, there's
incorrect. Very incorrect.
Which one entire world.
There are at least 100 separate moons in our solar system with liquid water.
Really? Okay.
Yes. One of them is Europa, which is made of
water. No, I was thinking Europa. Fuck.
No, Io is the volcano world.
Volcano world.
It's the hottest place in our solar system, short of.
I had a planet to bring up.
And that Europa is Saturn.
Yes.
No.
Supposedly there's a planet that absorbs sun. It's like eternally dark. Almost.
It's eternally dark on the world. Yeah, I've heard about that exoplanet. The atmosphere is made of a very thick molecule. It's a gaseous molecule, and it just absorbs sunlight. It's just like the ultimate form of, like, if you go onto the surface of Venus, other than the hot glow of the ground, it's pretty much dark on that planet because of the cloud cover. Interesting thing about Venus is that if you hover at a particular point, about 90% of the way into its atmosphere, it is one atmosphere dense, rains sulfuric acid, but, however, it is room temperature.
Yeah.
So the plan is to, we're going to be building a colony on Venus in the year 2024. It's already a planned escape. It's going to be done with an inert helium balloon, basically.
Really?
Yeah, and they're going to be hovering at that 1 atmosphere of pressure. You can actually walk out without a spacesuit on because there is a thin oxygen layer there. They can pump in the oxygen and pump out the sulfur dioxide gas, and it's all pretty good actually. That their plan is to use that as a way base.
Nice.
And because we're more likely to build a colony on Venus than on Mars.
Okay, hold on.
It just seems easier on Venus.
We can go over this more.
And we have the whole planet's surface and a lot of energy there.
Guys, we're
geothermal.
I would like to end this particular episode here.
Yep.
More about space later.
More about space later. We definitely promise. So, thank you for watching, guys. It's been Drone.
Sorry.
And Kaboom.
And we will catch you guys next time. Once again, there are a bunch of buttons down below.
Click them.
Click them.
It's bait. Don't do it.
Yeah, it's bait, but
what happens when you click buttons on YouTube?
Also, comments. All the comments are fine.
Yep.
And we will see you guys next time. Later.